Find the values of a and b that make f continuous everywhere, where f of x is defined as x squared minus 4 over x minus 2 when x is less than 2, ax squared minus bx plus 3 if x is between 2 and 3, and 2x minus a plus b if x is greater than or equal to 3. So the first thing I'm thinking here is actually that this function is not defined when x is equal to 2. I wonder if there's a typo and that this middle piece where x is between 2 and 3, I think it should be greater than or equal to 2 and strictly less than 3. Otherwise, it's not defined at the point 2. So aside from that, the way I'm going to solve this, we're basically going to kind of figure this out from left to right for the values of x. So we have this function plotted, or we have this function defined for x less than 2. We're going to want to take a limit as x approaches 2 from the left, in which case we use the first part of the definition of f. And we want to make sure that that's equal to the limit as x approaches 2 from the right. And we're going to use the second part that defines f of x with the quadratic expression. So this should give us an equation that has to be satisfied between a and b. And then we'll do something similar for x, limiting x towards 3 from the left side and the right side. This will give us another equation that has to be satisfied for a and b. We'll have two equations and two unknowns, and we can just solve. So I'm just going to write down this function, write down the set of equations that I need to be solved, and go ahead and solve them. The only sort of intermediate step here is I will have to evaluate the limit as x approaches 2 from the left of the first expression in order to know what the function is supposed to be equal to at 2. And so looking at that expression, I notice the numerator is a difference of squares, and we'll get a cancellation of something in the denominator. So it'll be a fairly easy limit to evaluate. So I finished this first part of evaluating the limit of this expression as x approaches 2 from the left. We get this cancellation in the numerator and denominator, and so the answer is just going to be 4. And so what I want is when I substitute 2 into this expression, I want that to be equal to 4. And so that'll give us the relation between a and b, or the first of two relations between a and b. All right, so now what I need to do is I need to take a limit as x approaches 3 of this quantity, but this is a polynomial, which is continuous, so I know I can just substitute 3. There's no shenanigans with limits or anything like that. We just substitute 3. And I'm also going to substitute 3 for x in here, and those expressions should be equal. So this is unfortunate because, oh, I see my mistake. Yep. This is a system of two equations and two unknowns, but if you look at the coefficients here, they're all multiples of each other, and a different multiple in this. So there's no solution to this system of equations for a and b. And I see I've made a mistake here in some of my arithmetic in simplifying this expression. So I'll go back and fix that. So I end up getting that a and b are both equal to 1/2. I suppose I could check very quickly that this works. Okay, so the first part works because when I evaluate the function at 2 using that quadratic expression, I get the same thing as the limit that I had evaluated earlier. So now let's evaluate this thing at 3. So if I use the expression for x less than 3 and substitute a 3, I get 6. Let's make sure I get the same thing when I use the other expression, 2 times 3. Well, a and b are both equal to 1/2, right? So negative a plus b is 0. And I once again get 6. So these being equal means that the function will be continuous. Yeah, this is a nice problem, fairly straightforward what we had to do. We're just making sure that when at all of the boundaries of the intervals where f is defined piecewise, we just want to make sure that the function evaluates to the same thing, regardless of which of the two expressions we use. So by enforcing that constraint, we ended up with a system of equations for a and b, which was pretty straightforward to solve. If I have more to say, I'll write it down in the description. Otherwise, thanks for watching.